Hello, this is Mr. Roush teaching you Module 10.1, Properties of Dilations. Our essential question is, how do you describe the properties of dilations? So what we're going to do is we're going to skip over to page 316, and we're going to first look at the exploring dilations on a coordinate plane. So what we want to do is first write our x and y vertices from our original shape. So you can see that the blue shape is the original one because they do not have the primes. So I'm going to start off with vertex A here. So A, if you look at this point A up top here, is at -2 to the left and then 5. So we're going to write -2, 5. Now for coordinate B is going to be right there. So there's coordinate B. That is at 4, 2. I'm just going to fill in the rest of these. C is at 4, -4. And D is at -4, -4. Now I'm going to go ahead and do this with the same, with the new shape after our dilation, which is, you could tell it's the new one because of the primes. So you have like A prime. A prime is at -1, and then it's right between the 2 and the 3, so I would say 2.5. B prime, which is right here, is at, you start at the origin, you go to the right 2, up 1, so we have a 2, 1. C prime is 2, -2, and D prime is -2, -2. So I know it says the ratio of x coordinates, it's the primes divided by the non-primes, and the ratio of the y coordinates, the primes divided by the non-primes. I like to write this as new divided by original. That just seems to make a little bit more sense to me because the new one are the primes. So if we look at just the x coordinates, our new one here for the A, so A prime, the x coordinate is -1 divided by -2. So -1 divided by -2 is actually 0.5 or 1/2. So now we're going to do our B prime, the new B prime. So 2 divided by 4 is 2/4 is 1/2. Or you could put 0.5. It doesn't matter. They're the same things. So then we're going to take our C prime, just the x value. We're going to do 2 divided by 4. So 2 divided by 4 is 1/2 or 0.5. So you can already tell right now that this is a scale factor and it gets smaller. So your number is going to be between 0 and 1. So our D prime, -2 divided by -4 is 0.5. So that would be the new divided by original. Now for our y's, we're going to take our new one, so our 2.5, divided by our original, which was 5, equals 0.5. So then we're going to take our 1 divided by 2 is 0.5. So if you could tell, these are all 0.5. So it says, write a conjecture about the ratios of the coordinates of a dilation image to the coordinates of the original figure. So you can tell that it gets smaller, and it gets smaller by half the size. So the ratios are 0.5 or 1/2. And they're all the same, so the ratios are proportional. Okay, so if you look, so we're going to find a scale factor. So I was talking on Friday about an enlargement makes something bigger, a reduction makes something smaller, so this is something I would probably put in your notes, and the scale factor describes how much the figure is enlarged or reduced. So we did it first with our ordered pairs. Now we can actually do it with side lengths. So if you remember, we still have our new divided by original. So if you look here, an art supply store sells several sizes of drawing triangles. All are dilations of a single basic triangle. The basic triangle and one of its dilations are shown on the grid. Find the scale factor of the dilation. So remember, new divided by original. So your new is always going to be your primes. So if you look from A to C, your A prime to C prime, your new one is going to be, if you count up the boxes or unicorns if you're Peyton. So we got 1, 2, 3, 4. So A to C is 4. Now we're going to match that up with AC, the original one. So you could tell that the AC here is 2. So 4 divided by 2 equals 2. So it looks like it's a scale factor of 2, but let's just check the other side just to be sure. So if you look, the new C to B is right here, and we have 1, 2, 3, 4, 5, 6. So we're going to have 6. That's your new divided by original, which is the one without the primes. From C to B is 1, 2, 3. 6 divided by 3 is 2. So if you look here, the dilation is a scale factor of 2. Both of these triangles are the same exact shape. They're just different sizes, which means it is similar. So for number 4, it says, is the dilation an enlargement or a reduction? How can you tell? So what you learned earlier right up here, an enlargement gets bigger and a reduction gets smaller. So from the original shape, this triangle ABC, it definitely gets twice as big. So it would be enlargement since it gets larger. Also, any scale factor greater than 1 will be an enlargement. Any scale factor between 0 and 1 is going to be a reduction. So if you look here, we can find the scale factor of the dilation. You guys should try number 5 on your own. So you can pause the video, do the work, and then double check your stuff. But if you look, remember, new divided by original. The original is the blue shape, the bigger one, and the new shape is the green one. So you can already tell it's a reduction, or it's a reduction because it gets smaller. So I'm just going to check 2 of the sides. So I can do my new one. So D prime to E prime is 1, 2, 3. New divided by, now I'm going to match it up with a DE on the top. We have 1, 2, 3, 4, 5, 6. 3 divided by 6 is 1/2. Now I'm going to do it with the next one, which would be, we'll just do EF. So E prime, F prime, the new one is 2. The original, to E to F, is 4. 2 divided by 4 is 1/2. So the scale factor is 1/2 or 0.5. If you have any questions, I can help you out with that, but thanks for watching and good luck on your homework.